Saxon Algebra 1, Lesson 30. In this lesson, we study algebraic phrases and decimal parts of a number. The power of algebra is it makes difficult word problems easier to solve. But this is true only if you can translate a word problem into an algebraic equation or equations. The key to such translations is to learn how to translate certain words and phrases. For example, if a problem mentions the sum of a number and 7, you would translate this part as the algebraic expression n plus 7. We are using n for the variable that represents the unknown number. It is important that you know what certain words mean. We've seen these many times before. Sum means you add. Difference is what you get when you subtract. Product means you multiply. And quotient is what you get when you divide. Here are some examples. We will translate the phrases into algebraic expressions. 7 less than a number. Now you have to think about it. You might be tempted to write 7 minus the number. But if you think carefully, like for example, if a TV costs $70 and another one costs $7 less, you would subtract the 7, not the 70. So we write n minus 7, not 7 minus n. So 7 less than a number would be written as n minus 7, the number subtract 7. The opposite of a number decreased by 5. Decreasing something means making it smaller. So we start with the opposite of the number, negative n, and we subtract 5 because we're making it smaller. Twice the sum of a number and 7. You have to be very careful about this. It really says that you add the number and 7 and then multiply the result by 2. So we need to use parentheses. 2 times the quantity n plus 7. If the problem says the sum of twice a number and 7, that's a different story. We multiply the number by 2 and then add 7. So that's 2n plus 7 without the parentheses. Do you see the difference between these last two? It's very important. The product of 7 and the sum of a number and 10. We have to be careful on what we're multiplying. We're multiplying 7 times the sum, so the sum has to have parentheses around it. We write this as 7 parentheses n plus 10, because the sum needs to be done first. Now we consider decimal parts of a number. Many people call decimal numbers decimal fractions because terminating decimal numbers can be written as fractions. For example, the decimal number 2.4 can be written as the fraction 24 over 10 because the 0.4 is the tenths position. And this reduces to 12 over 5 if we divide top and bottom by 2. And the decimal number 0.000463 is the fraction 463 over a million. You have to trace the place values in this decimal number. The first place value is tenths, then hundredths, then thousandths, then 10,000ths, then 100,000ths, then millionths. So it's 463 millionths. We've been working problems concerning fractional parts of a number by using the relationship f times of equals is. We can solve statements about decimal parts of a number by using a slightly different relationship. D times of equals is, where D stands for the decimal or decimal fraction part of the number, and of and is have the same meanings as before. Here are some examples. 0.32 of what number is 24.32? We will follow our pattern. D times of equals is. In this case, the D is the 0.32. The of part is what number, so we will write Wn. And the is part is the 24.32. So there's our equation. We need to get rid of the 0.32, so Wn is by itself. We divide by 0.32, and of course that cancels it on the left. So we end up with Wn is 76. If you pull out a calculator, 24.32 divided by 0.32 turns out to be 76. What decimal part of 42 is 26.04? We look at our pattern. D times of equals is. The decimal part is what we don't know, so we will write WD for what decimal. The of part is 42, we have times 42, and the is part is 26.04. So we have WD times 42 is 26.04. We need to get rid of the 42, so we divide both sides by 42. 42's cancel. Pull out the handy calculator. 26.04 divided by 42 is 0.62. One last example. 0.42 of 86 is what number? Following our pattern, D times of equals is. D is 0.42. The of part is the 86. And the is part is what number? So we really don't have to do much here to solve this. We just have to pull out the calculator and multiply 0.42 times 86. That gives us 36.12. This is the end of Lesson 30. Your assignment, problem set 30 on page 127 of your book.